Good morning. Okay, today's lesson, 1.7, functions. This is an important lesson. You should make sure you understand what a function is. A function is a relation in which each element of the domain is paired with exactly one element of the range. To be a function, all x values must be different. We can't say it any plainer than that. So let's go ahead and highlight that for you, because that is extremely important. It can only be a function. It can only be a function if all of the x's are different. If two of the x's are the same, I don't care if you're looking at a table, a graph, a mapping, or a set of ordered pairs, it's not a function. Example number 1. Determine whether the relation 6, -3, 4, 1, 7, -2, -3, 1 is a function. Let me just go back to the pen element, excuse me. Okay, here we go. So my ordered pairs are 6, -3, 4, 1, 7, -2, -3, 1. So we should be looking at the x's. Are the x's all different?
Yes.
Good. That's all you need to do. Can the y's be the same?
Yes.
Yes, they can. Is this a function?
Yes.
Yes. It is a function, and I'm going to abbreviate it as fxn because each element, it's in your notes, you don't need to copy it, it's right above you, of the domain is paired with one element of the range. Or you could have made your life easy and you could have just said all the domain values are different. Are you with me? Okay. Determine whether 3x minus y equals 6 is a function. Now this is a review. I'm not holding you responsible for graphing a line. We're not graphing lines in this chapter. The equation is in the form of ax plus by equals c. The graph of this equation will be a line. How you can tell if a graph of a line is a function, it's called the vertical line test. And to use the vertical line test, basically what you do is you go ahead and you draw a vertical line through all of the points. And I'll show you what I mean. So if you were to draw a line through here, it only hitting the line one time. Your vertical line does not hit more than once. It's only hitting one point. Are you with me? So a vertical line that looks like this, the vertical line test, a line like this is yes, a function. A line like this is yes, a function. A vertical line is not a function because if you were to draw a vertical line, how many times would it hit? It would hit every single point. However, a horizontal line is a function. Are you with me? Okay, the vertical line test is also called the pencil test. Did you ever hear that term before?
Yes.
The vertical line test and the pencil test are synonymous. They mean exactly the same thing. Okay, so we have for homework tonight, let's look, page 10, numbers 1 through 12 all. So let's go ahead and look at a couple of these together. I want to do one of the harder ones. Okay, let's everybody look at number 5. Let's see if you can remember what I just said. Is it a function, yes or no? Bella? No, this is not a function. It's not a function because look how many every point is the same. Okay, all the x values are the same. Can the x values be the same in a function? No, they cannot. Okay, everybody understand what you're going to do. So you're going to draw a line through each point and then determine if it's a function. Does anybody have a question on 1 through 6, something that you're not sure of? Okay, 7, 8, and 9. 7, 8, and 9. Those are ordered pairs. I need to abbreviate this because we have not gotten into graphing lines yet. So let me change the homework and let's just say, at this point, omit 10, 11, and 12. Okay, and I'll make the change on RenWeb, and we'll make the change on that board as well. Can you just change that to make it say 1 through 9? And can you just change it over here to make it say page 10, 1 through 9 instead of 1 through 12? Technically, you should be able to do it. Please don't do your homework now because I have a really, really important part of the lesson yet. To find a function value, equations that are functions can be written in a certain form called function notation, often referred to as f of x. Students are like, what is this and why is it so hard? So I'm going to make your life easy. If you had an equation like y equals 3x minus 4 is the same thing as saying f of x equals 3x minus 4. What you're saying is, what is the value of this function if I were to substitute a number in? So if I gave you an example like A in your notes, and it said, if f of x equals 3x minus 4, find each value. What is f of 3? What does that function equal when I replace x with a 3? And it's a simple, simple procedure. So wherever you see an x in the equation, what are we putting in? A 3. So this becomes 3 times 3, which is 9. 9 minus 4 is 5. So you could say f of 3 equals 5. Are you with me? Okay, let's go ahead and try one over here and see how you do. I know it's in your notes, but I want to do this one with you. Can you read me what example B says?
F of negative 2 plus 1.
Okay, and read me the equation again.
No, the parentheses are only...
F of x equals what?
Oh, F of x equals 3, parentheses negative 2.
No, 3x minus 4. Was that the original problem? Yes?
Oh, yeah.
Oh, yeah. Okay, hold on. So the f of negative 2 is the only thing in parentheses. So let's change that for you. Let's get it correct. Anytime today you want to work. Okay, so this is a really good problem. I'm going to put an asterisk here, and I'm writing, this is important. It's important for you to listen and for me to explain what you're doing. So the rule says this: when solving something that's in function notation, now, f of x equals 3x minus 4 is the given equation. What we're saying is, hey, what does that equal when x equals negative 2? And then we have a plus 1. So what are we substituting in for x here, guys? We're substituting in what?
Negative 2.
So this would become f of x equals 3 times negative 2 minus 4 at the very end, because the negative 2 only was in parentheses. That's the only thing you substitute in for x. Then you continue with the given equation. Now at the very end, you add your plus 1. So this becomes a negative 6 minus 4 plus 1, or what, guys? Negative 6 minus 4 is a negative 10. Negative 10 plus 1 is a negative 9. Anybody have a question? Okay, let me just look and see if there's anything else that I want to go over with you. All right, so let's look at the problems that I've given you tonight. Okay, there are two equations. There are two different equations. One is f of x equals 2x minus 4. So if it asks you to find f with a given number, you use the f of x equation. Does that make sense? The other equation is g of x equals x squared minus 4x. So when you see something that says g of 2 or g of 0, then you use that equation. Are you with me? I'm going to give you another major hint when you're doing this. In the g of x equation, where it says equals x squared, if you were going to put a 2 in there, make sure anytime you substitute a value in for x to any equation that you put parentheses around it. So this would look like 2 squared minus 4 times 2. Then use order of operations and solve. Correct? So use the correct equation. Every year kids come in and they do them all with the f of x equation. You don't want to come in and get them wrong. Okay, so let's just reiterate that your homework again is page 10, 1 through 9, and I changed it, yes? And if I will get to RenWeb and change it when you guys are taking part 2 of your test. And then on page 11, you're doing 1 through 12 all. Again, it's not hard. And again, let me just make your life a little bit easier. There is enough room on this worksheet in your notes that you do not, and I repeat, you do not have to recopy it. Did you all hear me? So I'm giving you permission again. Can the homework be done right on the worksheet tonight? Yes, it can. Do you have to put it on notebook paper? If you so desire to do so, though, can you? Yes, you can. Does anyone have a question? Yes. On page 11? It's supposed to be 1 through 12. Okay, so let me make that change as well, and I apologize. All right.